So yesterday we solved this homogeneous equations which were in the form of a non-intersecting lines. Okay, so then we found the point of intersecting lines we did yesterday, right? So we took the point of intersection and then we shifted the origin to that point and then we converted to homogeneous and then we solved how we solve our homogeneous equations. Okay, so today we will do the case when equations are in the form of a parallel lines. Okay, so let us take an example over here. Equations are in case of parallel lines. Okay. Case of parallel Okay, so let us start with an example. Consider the differential equation dy by dx is equal to x plus y plus 4 upon x plus y minus 6. Okay, so now let us see that this appears to be homogeneous except for the part that there is a constant added over here. Okay, otherwise it appears to be homogeneous. Why I am saying appears to be homogeneous? Degree of x is 1, degree of y is 1, degree of x here is 1, y is 1. So every term over here appears to have the same degree 1. Okay, except for these constants over here which are of degree 0. Okay, so we have to get these constants out of the picture or do something else out of them. Okay, so now observe that these lines are parallel. Okay, form the equations over here. Okay, the corresponding equations are dy by this thing. No? So you will get x plus y is equal to minus 4 and x plus y is equal to plus 6. If I will try to solve this equation, so we will never get an answer. Why? Why we will never get an answer? What is the problem here? See, here you are saying x plus y is minus 4, here you are saying x plus y is equal to plus 6. Can that happen? If this statement is true, it will actually imply that 4 is equal to 6. Okay? So clearly these lines don't have a common intersection point. Okay? Otherwise, if they have an intersection point, that means this statement is true, which is a contradiction. No? Okay, so this cannot have a point of intersection. Okay, so this system has no solution. So anyways, we'll still go by the determinant method. What is the determinant going to be defined here as? 1, 1, 1, 1. All are ones, so it is 0. Okay. So this implies that the lines x plus y minus, if you want to write it like this again, x plus y is equal to 4 and x plus y is equal to 6 are parallel. So in this case we cannot do what we did yesterday. We cannot find a point of our intersection and perform a change of variable. Okay, so what we'll do here is, let what is the common part in both the lines, x plus y, right? So that common part I'll give it a name. So let z be equal to x plus y. Okay, let z be equal to x plus y. So what will a given differential equation become? Taking derivative here, so dz by dx, this will become 1 plus dy by dx. This is derivative with respect to x. Okay, so this is what you get. Okay, so thus this in other words implies that dy by dx is equal to dz by dx minus 1. Okay, so thus the given differential equation becomes what is the given differential equation? Dy by dx is equal to x plus y plus 4 and x plus y minus 6. This will become dz by dx minus 1 z plus 4 upon z minus 6. Okay, you can still simplify this, that is dz by dx, take that 1 on the other side, so this will become z plus 4 upon z minus 6 plus 1. So this will simplify to z plus 4 plus z minus 6 upon z minus 6, so which is nothing but 2z minus 2 upon z minus 6. Okay, I'll just keep this 2 common outside, z minus 6, and this is dz by dx. So we have this new differential equation over here. What can you see about this differential equation? This differential equation now is variable separable. You can take all the z terms on one side and take all the x terms on another side. Okay, this differential equation is come. This differential equation is variable separable. Okay, so this will become z minus 1 I'll write it like this. I'll keep that 2 on top. So now I want to integrate this expression over here. How do I integrate this? What is the integral formula for this LHS? RHS is very clear that this will become 2x plus c after integrating. What about this integral? So what should happen here? What will do here? What is the method for integrating this? Nobody knows. What we do here? We split the degree of the denominator and numerator is same. So what should be done? We'll have to only do algebraic adjustments over here. Nothing else is there for us, right? So what are the algebraic adjustments we can do here? So this is z minus, I can write this as z minus 1 minus 5. So this will become equal to integral of z minus 1 upon z minus 1 minus 5 upon z minus 1 dz. Okay. So now what? This cancels and becomes 1, and the other integral is nothing but integral of log over there, right? So this is nothing but integral of 1 minus 5 times 1 upon z minus 1 dz. Okay, so this integral becomes z, and this becomes 5 times log ln of modulus of z minus 1. Okay, and this on the other side was equal to 2x plus c. Okay, so what is this thing z? Z value was taken to be equal to x plus y, no? X plus y minus 5 times ln of x plus y minus this thing. Okay, so this is the final answer over here. You can't simplify this anymore. There are some simplifications, but that will not be anything useful. You can cancel one x on both sides and then take that 5 inside the log sign, and those are ordinary adjustments. Okay, yeah. So this is one problem of this kind. I'll solve one more problem. Okay, so let us consider this problem. Second example here, dy by dx is equal to x plus 2y plus 1, and you have here 2x plus 4y minus 1. Okay, so let us consider these lines now. Solution. Let us repeat what we had done in the previous problem. Finish the previous problem now, everyone. Okay, so let us start with this now. So consider the lines. X plus 2y plus 1 is equal to 0, 2x plus 4y. Okay, if you all want, I'll take this plus 1 on the other side and minus 1 on the other side and write it like that. Okay, so for these lines, I'll define the determinant to be equal to 1 2, the coefficients involved over here. So coefficient here is 1, coefficient here is 2, coefficient here is 2, here is 4. So this. So what is the determinant value here? 0 it will turn out to be. Okay, hence the lines are parallel. Okay, hence the two lines are parallel. So what are we going to do now? Observe this part in the second line. Your first line is observe. The first line is x plus 2y plus 1 is equal to 0. The second line can be written as x plus 2y minus half is equal to 0. What I have done, I have divided both sides by half. Okay, so 2 becomes 1, 4 becomes 2 and 1 becomes half, and 0 by half is 0 by 2 is 0 only. I have divided both sides by 2. So this is what I get. So what is the common part between both the lines? X plus 2y. Okay, so what I'm going to do is let x plus 2y be equal to z. So taking derivative over here, dy by dx, okay, is equal to dz by dx. Okay, but we want the thing in terms of dy by dx, right? So dy by dx is equal to half times dz by dx minus 1. Okay, so the given differential equation becomes yeah, so the LHS will become half times this, half times dz by dx minus 1, and the RHS will become, what is the question I had given you? X plus 2y I have taken as z. So z plus 1 and 2z minus 1 it will be. Okay, the denominator is z plus 1 and this is 2z minus 1. Okay, denominator will become 2 times z. Clear to everyone now how I got this 2z here? Okay, that 2 was common for x and y, so I can write it like this. Okay, so let us simplify this now. This 2 over here, I'll take it on top this side and multiply it over there. So dz by dx minus 1 2z plus 2 upon 2z minus 1. Okay, take this on the other side now. So dz by dx is equal to 2z plus 2 plus 1 2z plus 2 plus 2z minus 1 upon 2z minus 1. So this will become 4z plus 1 upon 2z minus 1. Okay. Now this is variable separable. This equation is variable separable. Four z plus 1 is equal to dx. Okay, so again it's the same degree term in the numerator denominator, so we have to adjust, right? So how will I adjust? First I'll have to make the coefficient same, no? So I have to balance this. These adjustments can be done in rough and be substituted again over there. So let us do it in rough only. So 2z minus 1 upon 4z plus 1 I have, right? So this I can write it as half times 4z minus 2 upon 4z plus 1. So this can be written as half times 4z plus 1 minus 3 and 4z plus 1. Okay, so splitting those terms over there, you will be left out with 1 minus 3 times 4z plus 1. Okay, so this leaves you with half times 1 minus 3 okay. So yeah, before integrating now, just to avoid the trouble of having that constant coefficient, what I'll do, I'll take that 4 also common out. One more step I should have done there. I'll take this 2 on top, so this will become 1 minus, I'll take 3 and 4 common now. So this will become z plus 1 by 4 dz so this will leave me with 1 minus 3 by 4 on integration of ln of okay. So this should be my final answer, just resubstitute for z. What was the z? X plus 2y, no? Okay, so 1 minus 3 by 4 ln of x plus 2y plus 1 by 4 equal to 2x plus c. Okay?
So you didn't multiply that 2 on top.
Where? Which two? Dear? Much prior to this? Yeah, I multiplied now. This 2 I took here. 2 z. Yeah, this one no. No, which one is saying?
So how you did that z minus half?
Where? Prior to this you're saying? Where are we?
Z minus half.
Where is z minus half?
So you multiply 2 with the numerator, but you multiply 2 with the numerator.
Here you're saying?
Yeah.
No, this step you're saying no?
Yeah.
No. I had taken a shortcut here. I thought you all understood. What is the given differential equation here for me? I had x plus y, x plus 2y plus 1, right? Upon 2x plus 4y minus 1. Okay, so what I've done here is I wanted to put only this common factor as z. Okay, so I put the x plus 2y in the numerator as this thing, and then here I have written this as x plus 2y minus half. Okay, so I've written it like this. So this has become z, so this becomes z plus 1, and this has become 2 times z minus half. I thought you are referring to this, no? Yeah. Before I showed this, I divided this. Yeah, this you'll continue with this. This I had just shown you for an observation sake. This is not to be included in the problem. Because if you had included this.
So, but even if we take that, the answer should come same.
No. Answer won't come same because you're not balancing. The I said will divide by 2 here now. Because I have equal to 0 in this equation over here. But in the given differential equation, this is not equated to 0 over here. So if you're doing the divide by 2 here, you'll have to do a divide by 2 on top also, no? That will kind of change everything. I thought you all understood that, so I went on aram se. You didn't ask me that time only. I had asked also, no, everyone got this. Okay, just keep this as a note then, huh? Actually, no, it will be better, no, instead of writing this, no. Actually, don't write this. Don't write this actually, this will be a bit problematic. So instead of writing this, no, because in future you will get confused also. So just refer to this expression here. Refer to this, the way I have done this, no. Okay, what is essential is this common factor thing, that you should see that there is a common factor. In the last problem, this common factor problem was not a, both were same. Here there is that common factor issue. Okay, this is a better way of looking at it than looking that way. That can get confusion. Okay. So that with that we are done with this. Yesterday's homework problem you have solved? Everyone solved, no? There's no issue, no? Okay, let us see if there's one more problem you have to solve. What is the question I had given you, by the way? Can I just repeat the question?
X plus 3y minus 1 dx minus 4 x plus 1 dy is equal to 0.
Okay, so this was okay, no? So there's one more problem here, we'll try that. There's one more problem here since this time. This is based on yesterday's type if I'm not wrong. Okay, so what? Solution. Yeah, no. Okay, write this down. Two x minus two. What happened? Finished? Sideways thing you didn't copy. So here there's a mistake, no? So this will become z. This will become z and this will become x plus 2y. Okay. So this will be my final answer. Just 5 minutes now. I'll just try to finish that problem in 5 minutes. I'll solve it at least halfway. So the question number 3 was 2x minus 2y dx, okay, plus y minus 1 dy is equal to 0. Okay, 2x minus y dx plus y minus 1 dy is equal to 0. So, what are the equation of the lines? Consider the lines. Two x minus 2y is equal to 0, and here you have y is equal to 1, the second line. Okay, y minus 1 is equal to 0. I took the 1 on the other side. By the way, the first line can be written as just x minus y is equal to 0 because the 2 can be cancelled out over there. Okay, but let it be now. So determinant will be what here? Determinant of this quantity will become 2, 2, 0, 1. Okay, the coefficient here is 2, 2, 0 over here, 1 over here. Minus 2, minus 2, minus 2. So the final answer comes here as 2, that is not equal to 0. Hence the lines intersect. Okay, hence the lines. Okay, so we'll have to find a point of intersection. A point of intersection becomes very easy here. You have the equations 2x minus 2y is equal to 0 and you have y is equal to 1. So clearly this one has given you y is equal to 1, and clearly the first equation will give you y is equal to x is equal to 1. Take y is equal to 1, substitute in the first equation, you will get x is equal to 1. Okay, so the point of intersection is 1 comma 1. Okay, the point of intersection is point of intersection is 1 comma 1. Okay, point of intersection is 1 comma 1. So what should be our change of variables? Define capital X as small x minus 1 and capital Y to be small y minus 1. Okay, just the subtraction of these quantities. So in other words, the small y should become capital X plus 1, small x, and small y should become capital Y plus 1. Okay, let over here, let this happen. Let this be true, then this follows, and then also you have dx is equal to capital Dx and small dy is equal to capital Dy. Okay, just writing. Okay, I'll write down here only to avoid a scroll. So what should be the given differential equation? It will be capital Dy by capital Dx is equal to, oh, I had not written this equation in that form now. What will it be, by the way? Dy by dx, I'll take d on that side, y minus 1 in the denominator. There's a minus sign here, so just keep that over there. So this will become 2 times x plus 1 2 times x plus 1 minus 2 times y plus 1 upon the denominator term over here will be capital Y plus 1 minus 1. Okay, so you should end up with minus 2x plus 2y upon y in the denominator. So this will become 2 y and y will cancel and write down the side. Okay, so this will become 2 minus 2 x upon y. Okay, minus 2 x upon y it is, but this can be thought of like this, 2 minus, right? Okay, clear? So now I'll just do the substitution. It's in homogeneous form right now, so I'll this thing, put y by x is equal to, what I'd used alphabet, u of z, no? Okay, so Okay, y by x is equal to z. So y is equal to xz. So that is going to give me dy by dx equal to z plus x times dz by dx. Okay, so substituting back in the original equation, that will leave me with z plus x dz by dx is equal to 2 minus 2 by z. Okay, so just going back here, x dz by dx, taking this term on the other side, so you have 2 here, you have 2 minus z minus z. Okay, this will have to be simplified, this quantity, multiply z on top, so this will become minus z square plus 2z minus 2 upon z. Okay, there are many 2's over there. Okay, x dx. So take this on the other side, this will become as z upon minus z square plus 2z minus 2. Okay, this is x dx. This minus sign can be adjusted on the other side. We should have left it and gone there only. Okay. Okay, now there will be a partial fraction simplification here. So I think so we'll stop here. Okay, this will take time, it will be late then. Okay, so we'll stop here. Okay, so let us continue with this, what we are doing. So we had got z is equal to this thing. Alright, so I'll do some simplifications here before proceeding. This I'll write it as z square minus 2z, okay, minus 2, and I'll take this 1 over here, minus x dx. Okay, next this denominator, sorry, this should be plus, no? It shall be plus. Okay, so z square, z, this can be simplified as capital Z. So capital Z, what are the factors here? It should become, can this be factorized? Let us see if you can find the factors of this. Z square, I'll just write with shorthand notation, 2z plus 2 this thing. So z should be equal to minus b, that should be equal to plus 2 plus or minus b square. B square is 4 minus 4 times AC. 4 times AC. 4 a into c, so 4, this will come 8. 4 into, sorry, 4 into 2, that is 8, 48. 4 into 2, that is 8 upon 2 times a, that's 1. B square. Okay, so this has complex roots. We're kind of stuck with this partial fraction simplification here. This is not a correct way to do it. Okay, so this partial fraction technique won't work here. So we'll have to adjust, since the denominator is of degree 2 and numerator is of degree 1, we'll have to make adjustments. Okay, we'll have to adjust the terms and cancel them. So this partial fraction simplification won't work. Okay, so we'll have to adjust the numerator as the derivative of the denominator. Okay, so now let us do this in rough and then we'll go back. What is the denominator? Z square minus 2z plus 2. Derivative should be 2z minus 2. But what do we have in the numerator there? We have only z. Okay, we require 2z minus 2. Right? So how can I write z is equal to this? I'll have to first add and subtract minus 1 and plus 1. Okay. but even that will be helpful. Doubt this will also work. Now we'll get stuck with this anyways. Okay, never mind, we'll try. So this I'll write it as 2 times this this is that form, a times d by dx of denominator plus b. This is one of the methods which I learned for integration now, so I'm doing that indirectly. I'm just taking some shortcuts here, this way I'm not showing all the steps. Okay, yeah, so what I'll do here, I'll adjust and this with 2 uh, and here I'll multiply 2 on top. Here I'll multiply 2 on top, so 2z minus 1. So now it will become derivative of the denominator, this thing, and this half will be just a constant over there, and this will come with that term over there. Okay, so let us see if we can do this one. I feel we'll get stuck on it. Okay, so basically I'm saying that this expression z upon z square minus 2z plus 2 plus 2, this can be written as half times 2z minus 2, okay, plus 1, okay, and this will become z square plus z square minus 2z plus 2. Okay, so half times this expression 2z minus 2 upon z square minus 2z. So this we can first terms integration we can do, second term will again with the same problem. Okay, so this technique is also not going to work here. This technique of splitting everything works now if you have real roots. If you have complex roots now, everything is gone. Actually, what's wrong with complex roots now? Wait, partial fractions will become difficult. Complex roots, not impossible but difficult. Let me just check if I've done everything correctly in this problem. Check. Let's start with the beginning of this problem. This was the given question to us: 2x plus 2y. Okay, this part will be correct because we got a sensible equation here. If that point of intersection part and all is wrong, no, you will not get a constant. You will get equation remain, the constant term still there. The constant terms are eliminated, that means you're correct. Okay, so this part was correct. So 2x minus 2x plus 2y upon y. So this is what we ended up with over here. Minus x by y plus y, and that I wrote it as y by x. Y by x. So z x plus dz by dx z plus x plus dx. 2 upon 2z. So this will get, this will go this side, so this will become z square. This I made minus z square. Okay, this will become plus 2z, and this is minus 2 as it is. Okay, then I actually later on adjusted the signs. This x was supposed to go down anyways, but that will not affect us in any case with our solution. We discovered here that the roots were becoming complex, so I was worried. Okay, but anyways, what are the complex numbers also? It's not a big difficult complex number. This will become root over 4 minus root over minus 4 upon 2. So this will become actually 2 plus or minus is there, 2i upon 2, which will give you as 1 plus I. Okay, this is your final answer. One plus I is your final answer. Okay, so sorry, 1 plus I and 1 minus I is the answer. So the values of the roots here are z is equal to 1 plus I and z is equal to 1 minus I. So basically the denominator term z square minus 2z plus 2 can be expressed as the product z minus 1 minus I into z minus I plus I minus 1 plus I. Okay, it can be expressed as the product of these two quantities. Okay, so if you agree to that, then you still have to do partial fractions with this. Okay, you still have to do partial fractions here, even if you can do the split. So anyways, we were left out at this stage, right? So that expression over there for integration was half times 2 times capital Z, 2 times capital Z minus 2 upon z square minus 2z plus 2. If you are getting confused with my z now, then I'll write small z or do some changes in the alphabets because there are 2's over here. Okay, so yeah, this can be split into okay. Okay, so this I can split into z minus 1 plus I and z minus 1 minus I. Okay, okay, so this I can use partial fractions now, something I'll have to do. I think so this will be an easy split, so I don't have to worry about this. Let me just try this. I'll try to do it manually. Okay, so let, if possible, you write this as z minus 1 plus I, and you write this as z minus 1 minus I. So if you cross multiply, you'll get the denominator. Now if you take this on top, okay, if you take this on top here, this will become, this term going on top here will give you z minus 1 minus I, and this term going up here, I think so I'll have to put a minus sign in between, so this will become minus z plus 1 and minus I. Okay, just let me verify this. I have done this calculation in my mind. I'm not going to the partial fraction thing. So if I do this cross multiplication, this will give me z minus 1 plus I, sorry, minus I on top, minus I on top, minus z minus 1 plus I upon the denominator, that's the product of z minus 1 plus I and z minus 1 plus I. Okay, so it's the denominator after cross multiplying this expressions. What will happen is z will cancel, 1 minus 1 will also cancel. What will survive is only I and minus I over here, right? So that will leave me with minus 2I in the numerator and the denominator, z minus 1 plus I. Okay, but I wanted the product to be equal to this, not this. I got this extra minus 2I in the numerator, right? So what I'll do, I'll balance it over here. Okay, simple it is. It's minus 2I in the numerator, minus I minus I here. So minus 2I. Okay, if you do partial fractions, you'll get this a is equal to 1 upon 2I and b is equal to minus, there's a minus here. So a will come as minus 1 by 2I and b will come as plus 1 by 2I. Yeah? This will become plus because of this minus sign. But never mind, so we're done with this problem. It was a little lengthy and twisted. I hope I didn't make mistake anywhere in this calculation. Otherwise, this was okay. So finally we are here, 1 upon 2 2z 2z minus 2 upon z square minus 2z plus 2. So that entire expression becomes this, and the integral of that side will become, this is half times numerator, right? Numerator is derivative of the denominator, so it will come half times ln of denominator. So z square minus 2z plus 2 minus half 2I ln of z minus I plus 1, and this will become plus 1 upon 2I. I'll multiply this inside, ln of z minus 1 minus I. Okay, so this is all what we have left with. Resubstitute now. Z is equal to y by x, you put capital Y by capital X. Oh, this is not the original solution to the problem. So the original solution is there on top. But anyways, we'll substitute, we'll simplify this and then we'll proceed to the original solution. So this is half times ln of y square by x square minus 2 times y by x plus 2 Okay, 1 upon this I can combine. This is numerator subtracting the denominator, right? So 1 upon 2i. So this is 1 upon 2i, you keep out common here, right? And this is going to be ln of, I'll write it down to avoid confusion, ln of y by x minus 1 minus I minus ln of y by x minus 1 plus I. So this is log of a minus log of b, so that will become ratio over there, and this will just cross multiply. So this will become half times ln of y square 2xy okay upon 2x square upon x square, and this will be 1 upon 2i bracket ln of, see now I'll just do the simplification, y by x 1, I'll write it like this, it will be better, and this upon y by x minus 1 minus I. Okay, if I take this minus sign common, this plus will become minus 1. Okay, this, yeah, so you can just take this x on top here and cancel the x in the denominators. Okay, you all write it as one extra step. Okay, write this step and then write one more extra step on, because you all can't overwrite in your books, I can overwrite over here. So this will become yx and 1x will cancel out like that now. Okay, cross multiply and the x in the denominators will cancel. So this is what you're left out with. Okay, so this is what we get. Not a nice thing. Still we are getting an answer like. So going ahead, if this is this thing, oh my page got over here. Shit. This is more trouble. So let me write down the full solution here somewhere. So what is my final solution? I'll be having half times ln of y square plus 2xy plus x square upon x square. Okay, this should have been 2x square. Where did the term come? Yeah, 2x square, no? Oh, and it's a minus 2xy. It's 2xy. Okay, so 1 upon 2i ln of y plus y minus, if I'm not wrong, both places minus. Okay, that thing 1 plus I, let me just check this out, wait. Okay, let me just check this if I've written it correctly. Oh, it was plus I in the numerator. Plus I and, oh, I got it correct. both places minus, but I got it correct. Okay, and this is going to be, the RHS integral was supposed to be ln of x plus ln of c. Okay, so this is your final answer. Now we have to substitute for capital X and capital Y. So where did we start the problem? There it will be. Let me just zoom out, I'll find it easier. So what we have taken capital X to be? Capital X is, you see, here we have taken capital X to be x minus 1 and capital Y to be y minus 1. Okay. Okay, so x minus 1 and y minus 1. So that will be the last simplification. I don't want to do anything more. Huh? So finally resubstituting, this will be half times ln of small y minus 1 the whole square to small y minus 1 small x minus 1, okay, plus 2 capital X, that is x minus 1 the whole square. Then this term 1 plus 2i ln of y minus 1 minus 1 plus I x minus 1. So y minus 1, keep this in the bracket, minus 1 minus I x minus 1 ln of x minus 1 plus ln of c. Yeah, you could have combined both the statements. Ln of cx, you could have made it. I forgot to do it. Okay, but anyways, we'll stop with this. So this was a big problem with a, not, it looked very small problem, it became big because of the complex roots over there. Okay, so yeah, so that's all over here. Okay, so we'll stop with this. Okay, so that's all, we have finished this particular subtopic. Next time we'll start with a new subtopic. Okay, bye bye.